this hypothesis testing, I think we can cover in 1 or 2 classes. It will be finished. Rest will be based on the question. If you wish to do previous year questions, like I can share you one website I was able to find where a hypothesis testing question based on the previous year is given to you. You can just give it a try. Okay.
Okay.
This t-test is not in your syllabus, but yes, rest of 1A, 1B, 1C, 3 types of questions will be there in your syllabus. We discussed what is hypothesis testing in the previous class. One-tailed and two-tailed stand for. And before this, I should also tell you about the hypothesis testing.
The
Little bit
one-tailed
only.
was like one-sided, and two-tailed
Yes,
was you divide it by 2 and either side of it.
perfectly okay, perfectly okay. You are absolutely right there. So you will be having the situation. So how to define the upper tail? Remember, just for your reference, there are 2 types of hypothesis. One is null hypothesis. Just suppose we are talking about the mean. Mean is going to be say mu naught. So what you can see in this case, it is one tail and the critical region is on the upper side. So what is the alternative hypothesis for this case? H1 is going to be mu is bigger than
Not
mean.
equal. Bigger, because it's
Bigger.
single.
Yes. Okay.
Okay.
And let me just give me a second. So this is an example of a one tail. We call it upper tail. Similarly, there will
Upper
be a
tail.
situation when you will be having critical region on the left hand side. We discussed the meaning of critical region maybe in the previous class. So this is going to be the situation where the alternative hypothesis is going to be mu is less than mu naught. So the name here you will be using is going to be lower tail.
Okay, sir.
The name you will be using here, upper tail.
Lower tail and upper
And
tail.
yes, and there will be a situation where the critical region is on both sides. When the critical region is on both sides, so this is called two-tailed.
Yeah.
And in this situation, alternative hypothesis is going to be mu is not equal to mu naught. So you need to identify whether mu is bigger than, less than, or not equal to. And actually for one tail, it is enough to remember the z values only. Otherwise, everything will be obvious for you. But yes, you should be able to differentiate between one tail and two tail.
Yes.
In order to find the values, there is a table and you should be able to remember the table, or the table will be given to you. So whatever the situation, but yes.
We have some table for this, sir.
Yes.
Like
So
in our exams, we were given a data booklet for this.
perfectly okay. So let us just start the questions. I told you there are 3 types of questions only. For this Z test, that is 5.3, we are working for the situation right now. You need to identify for one tail, what are the Z values, and for two-tailed, what are the Z values, you should be able to tell. Okay, so the situation for the first case I'm going to discuss is, you need to talk about the mean, and the situation here will be the following. Testing mu when the population X is normal and the variance is known. So the situation here is, it is given that this X, the random variable, is normally distributed with the mean
known
mu and sigma square.
Mu squared. Sorry, sigma squared, yes.
Yes, and this sigma square is known to you.
We don't know mu.
No, we are testing for mu basically. We are testing for the situation of mu, but sigma is given to you. This is what the situation here. So whenever this is the situation, sample size will be denoted by small n there, and this can be any number. Like it can be 10, it can be 20, it can be 30. Okay, because there will be tests based on the large samples also. So I will differentiate when the large sample is going to be useful. Then in that case, when you take the samples, like the samples are x1, x2, and up to xn, these are the samples taken from the population which is normally distributed. That means these are the values of x. In that case, the sample mean, let us denote them by x bar, is also going to be normally distributed with the same mean mu and the variance sigma square by n.
So given that sample size equals n can be any number.
N can be any number, and it is the situation when it is given to you, population is normal.
Okay. I understood that. I understood the x bar and the mu squared upon n like we did last time. Can you repeat what was this x2 ... xn? What was this again?
This is nothing to do with the question we are going to discuss. In the question, they will tell you that we have taken 20 samples. So you need to worry about n equals to 20 only. That is number of samples. And then after they will tell you the sample mean is going to be this much amount. So this x1, x2, xn, it is nothing but the samples taken from a normal distribution. We need to worry about only n equals how many numbers are there, what is the mean there. Okay, we need to worry about these two situations only. It will not be relevant for you for the timing. Okay, for the timing. But yes, there are questions where they will tell you that these are the observations we have obtained. So if the observation obtained, I will ask you to find out this x bar only and do the basic like repeating what we have learned for the questions. You will have questions based on the same. We will discuss it. For the timing, you should focus only the number of samples you have obtained. Okay. So whenever x bar is going to be like this, so we need to identify whether we are going to accept the null hypothesis or we are going to reject the null hypothesis. Okay, depending upon the situation. For that purpose, I need the z values. And z value is going to be this x bar, the sample mean, minus mu naught.
Minus mu over sigma.
Let me tell you, h naught was it was mu equals mu naught. And so h naught, h1 was mu bigger than mu naught, mu less than mu naught, and mu not equals to mu naught. These are the three possibilities. Okay, this x bar will be either given to you or the sample will be given to you. You will find this. And you divide by this number sigma over square root of n, like we did. You calculate this number. So just suppose I'm talking about one tail. One tail stands for right tail for the moment. Just suppose this is the right tail.
Yes.
This is going to be the critical region. So in case if the value of z lies such that this is going to be, this is the area of rejection basically. So whenever the value of z lies in this part, and how can I ascertain? Just suppose the value of alpha is given to you like 5% for you. For the 5%, the value of z for one tail is going to be 1.645. So this value of z alpha is 1.645. In case the value of z you obtained, it is bigger than z alpha. So we reject null hypothesis.
Okay,
that is the only situation. And if it is less than, so we do not reject null hypothesis. That is the only situation. Any doubt?
No, sir.
Perfectly okay. So let us have a quick question based on the same. You know about the values of z. So let me just, this can be a repetition, but don't mind because we are going to complete this one part, that is the normal distribution today. Just try to complete everything in a class.
Okay, sir. Yes.
Read the question, please.
Each year, trainees throughout the country sit a test. Over a period of time, it's been established the marks that can be modeled by a normal distribution with a mean 70 and standard deviation of 6. This year, it was thought that the trainees from a particular country did not perform as well as expected. The marks of a random sample of 25 trainees from the country were scrutinized, and it was found out that their mean mark was 67.3%. 63.7.
Perfectly
Does
okay.
this provide evidence at 5% significance level that the trainees from this country did not perform as well as expected?
Perfectly okay. So if you look at the question, it is given to you that the population is normally distributed. I highlighted that portion with the mean
Yeah.
given to you and with the standard deviation given to you. So up to this point, I can tell you that my X is going to be normally distributed with the mean 70 and standard deviation is 6. So I'm writing 6 square because this is variance for you. Right up to this point. Then
Yes.
after you have taken a sample, for the sample size is n is going to be 25 for you. And X bar, the sample mean, it is given to you 67.3. So what is expected here? And that this X bar, it is less than mu. Am I right?
Mm,
Mu, basically it is mu
yes,
naught. Mu naught.
because they claim that they performed less than expected, so it will be
Perfectly
less.
okay. So it is as per the observation. So in this case, because the population normally distributed, what we have that the sample mean is also going to be normally distributed with the same mean mu, whatever given to you, and the variance is going to be sigma squared divided by n. So this is going to be n, mu is going to be 70, sigma square, that is 6 square divided by how much? 25. Any doubt up to this point?
No, because it's sigma squared upon n, that formula.
So it is a sigma square upon n without any issue. Okay, so let us have the null hypothesis that no, there is the average is going to be 70 only, performance average. Alternative hypothesis say no, there is a decrease in the average than 70. This is what I told you. It is 67.3 less than 70. So there is a decrease. Are you able to recognize? It is decreasing. So it is a one-tail situation for you. Clear term? So we will try to find the Z value. And what is the Z value? Z value is like this X bar minus mu naught. This mu naught is 70 for you. Right? This mu naught is 70 for you.
Yeah.
Divide by sigma upon square root of n. So X bar is what? We are having 67.3 minus 70 divide by sigma was 6 divided by square root of 25 is going to be 5. Can you please use your calculator? Tell me the value. And meanwhile,
63.
yes, please.
Yeah, 67.3 minus 70 divided by 6 by 5, right?
Divide by 6 by 5, yes.
Minus 2.25.
Minus 2.25. Minus 2.25. So check, I have written the values. Let me just write down. Z alpha is negative 1. This is 645. This is what we have known. One tail, and it is going to be left tail, that means lower tailed. Okay, so check.
Yeah.
The value of mod Z is 2.25. It is bigger than, so mod of Z alpha. Can I use this word? Just check.
Mode is 2.25 because this is the mean you're saying? No.
See, the value of Z we obtained is negative 2.25. Yes or no? The mode
Yes.
of the mode is going to be 2.25. What is mode of Z alpha? It is 1.645. So 2.25 is by default bigger than 1.645 without any issue. Whenever this is the situation in one tail, whether it is right tail or left tail, that is upper or lower, if this is the situation, what we say statistically, we reject the null hypothesis.
Okay, we'll reject the null hypothesis in this case.
Always remember, because there can be negative issue, there can be positive issue. Whenever mod Z is bigger than mod of Z alpha for one tail, whether it is negative, positive, whenever this is the situation, you reject the null hypothesis, that is H naught. So,
Understood.
and that is going to be the answer for us. So that means yes, there are changes. So let me just write down the answer for this question. Check. There is evidence at 5% level that the trainee in this area have not performed as well as experienced, because we are rejecting H naught, and H naught is rejected in favor of H1. Any doubt?
No doubt, but how can you like say it's the mode is 2.25? I just wanted to like
Okay.
reconfirm.
Okay, let me just tell you about the situation and how to deal with this. Try to focus on the situation. There are two things you need to focus.
Yeah.
Either you are working with the lower tail or upper tail. For the lower tail, alpha
Right,
for
so
say 5%, the value of Z alpha is going to be negative 1.645. And for upper tail, for alpha equals 5%, the Z alpha is going to be how much? 1.645. So the only difference is of negative positivity.
that's right.
So just, yes. So basically, if you just try to draw the graph, so Z alpha will be somewhere here. Yes or no?
Correct.
And this is the area of rejection.
Yes.
Clear? The value of Z we obtained was negative 2.25 if not an issue. So this
No issue.
value Z will be somewhere here. This is going to be
Yes.
negative 2.25, and Z alpha is at this point. What the value is? 1.645 with a negative sign. So whenever the value of Z is less than Z alpha, so in this case we reject. We reject null.
We reject. Yes, I
Reject
got
null.
that. But what
I'll
did you mean
explain.
by the mode of them?
Just give me a second. If this is the similar situation, you are having Z equals 2.25. So you will be using the word whenever Z is bigger than Z alpha. So we reject null hypothesis. Just suppose this is the case.
Yes.
So now the question is, I need to focus on whether it is a left tail or right tail, because the negativity and positivity matters. If you wish to use them, you can use them. Alternatively, what you can combinedly say that whenever mode of Z is bigger than mode of Z alpha, mode of Z alpha is always 1.645 without any issue. And I need not to worry about the negative positive sign. Whenever this is the situation, I'm going to reject null hypothesis. So in this case, so it is going to basically serve for both the cases. Even if it is lower tail, you will be having the same situation. You can verify how, because Z was negative 2.25 and I told you it is less than 1.645 with the negative sign. Am I right? Just take the mode.
Right, sir.
So mode of Z is going to be 2.25, which is bigger than mode of Z alpha. So it is an equivalent condition. So either you use Z less than Z alpha for lower tail, or you use Z bigger than Z alpha for upper tail, or combinedly you can use this statement for both.
Okay, so it's either choice. We can use
Yes.
that statement or we can use the mode thing.
Yes, it is the same thing for you. So if you have a normal distribution graph, give me a second, please.
Yes, sir.
If you have a graph like this, and this is going to be, say, a Z for you, a small z, bigger than Z alpha. So capital Z will be any value after this. That means probability of this reason, it is denoted by probability of capital Z is bigger than small z. This is going to be 1 minus phi z. Phi z is going to be the standard for the standard normal distribution. It is the cumulative distribution function CDF for you. This value is denoted by P there. Any doubt? And
repeat,
this,
sir, your voice is not clear. Hello? Hello?
yes. Am I audible to you now? Am I audible?
It's like your volume is a bit less.
Uh, can you please check your connection?
Ah, now it's better. Now I could
Now
hear
it
you
is.
properly.
Okay. Okay. Perfectly. Okay. So
I
in
think
this
the
case,
microphone distance was the problem.
I don't think so because
Now it's
uh,
better, yes.
now it is better. So basically, you try to focus on the value of P. So the value of Z they are going to mention for you mention is going to be 1 minus 5Z. So if it is not an issue, we know that I told you some value like 1.645. Do you remember?
You 1.645 and minus 1.645.
Yes. So basically, this is the value. P stand for 0.05, that is alpha equals to 5% level. This is given to you, right? So I
Yeah.
told you this is the value of alpha equals like 250. This not 250. Just focus on the next one. This is going to be at alpha equals to 1% level of significance. The value is 2.33. So 2.3263. This is the value you can use. It is up to you. So these are the values of Z alpha given to you.
Yes,
Are you
sir.
getting the point? And these values are for one tail. For two tail, you are going to just suppose if alpha is going to be 5%, and all these values are
We will
given to
halve
you.
that.
Yes, one tail. So in the situation here, you will talk about what is alpha by 2. Alpha by 2 is going to be 2.5%. 2.5% is going to be 0.025. Do you remember? Do you agree with this? And
Yes,
you are
sir.
going to use that value. So basically, this is going to be the value of Z alpha for alpha by 2. That is 5%. So depending upon it is one tail and two tail, you are going to use these values. So in a way, they have given these values. And when I started, I have given you this table. Check, these are the same values you will be using. Depending upon 5%, 1% level of significance. I told you what is the value of Z 1.645. So basically, they are using this value.
Yes, sir.
Just check if you are able to relate. And that is where they are using Z alpha. So you can use
Okay.
these values without any issue. Any
And
doubt?
what was on the other side of the table? Because there were two parts of it, wasn't it? Like on the left of this were also some values.
Yes. On the left of this, if you just talk about, give me a second. Just try to understand what the situation here given to you. Okay. So there is a bell-shaped curve
Yes,
without
sir.
any issue. Just suppose this is the center for you given to you. This center stands for Z equals 0, right? So the situation here is whatever P, small p is representing probability of Z bigger than equals to this value of Z, that is small values of Z given to you. So 0.55 stand for this complete area is 0.5. Yes or no? This
This
complete
has
area
a 0.5. Yes.
0.5. This is what the probability given to you.
Mm-hmm.
Clear?
And the Z value
Second,
is 0 in this case.
yes. Now the second situation is whenever the Z value is going to be 0.2533. So the
Mm-hmm.
probability of this whole region is going to be 0.4. This is what
Ah, now
given
I
to you.
see.
Okay.
So those two are like the opposite tables sort of thing.
Yes. So basically, when you go for this Z value is 0.5244, you have 0.3 there. This is how they are interpreting these values. Any doubt?
No doubt, sir.
Perfectly okay. So we will be using the Z values like they have given to they have given here, and I searched for 2 to 3 documents everywhere. They're trying to find the Z values, but yes, there is an alternative way also. If you wish, I can tell you that alternative way.
Or
Should I tell you
finding the
that?
Z values using these tables.
No, see, Z values we have obtained, and I told
Yes, sir.
you I can tell you questions based on finding this probability without
Okay,
the
sir.
Z values. Okay. That is
Yes, sir.
also possible. Let me just show you this. The same question I will be repeating. Give me a second, please. The same question I will be repeating. Just please try to help me. This is going to be case of null hypothesis is mu was 70. Alternative hypothesis is going to be mu is equals how much? Mu is less than, basically less than 70. This was the question for you, right? It is going to be
Yes,
left
sir.
tail for you. It is left tail for you. So the situation will be something like that. And
Agreed.
this is, yeah, this is going to be alpha equals 5%. This is going to be 5%. This is going to be area of rejection for you, right?
Right.
Right up to this point. So what I will do, I will try to find out the probability that capital Z is less than equal to small z. Okay, this I will try to find out, and based on that, I will be finding the answers. How should I do this? In order to find this value, let me just try to find out the probability that the sample mean it is less than 67.3. Check once more. What I'm trying to find out, I'm telling you once more, it is given to you that the distribution is normal with the mean 70, standard deviation 6. There are
Yes, sir.
25 trainees there, and it was found that their marks and their mean marks are 67.3.
7.3.
67.3%.
Agreed.
Okay. So I need to find out what for 67.3, what is going to be the value of Z. This is what I
Probability.
need to find out. Okay. Or the probability.
Yes.
Right now I'm working with the probability. For the normal distribution, what you do, you subtract mean, divide by sigma upon square root of n, which is going to be 67.3 minus 70 divided by sigma, that is 6 upon square root of 25. Do you agree? Anything? Any issue up to this point?
Yes, this is the same thing what we did last time for this part.
So this is going to be PZ. Z is less than going to be how much? It is negative 2.25.
0.25.
Now you use the
Yes.
normal table. Give me a second. Let me just find a normal table.
Like the tables on that booklet or a different one.
For the time being, if you wish, I can use the table basically, normal table. Give me a second. Because whenever you use this type of situation, you need to find the normal table. Okay, look at the normal table. And I hope it is readable. The situation you should focus is Z is less than negative 2.25. Can you see that table?
Z is negative less
Less
than
than
negative 2.
negative 2.25. So let me just show 2.2 is the row. 2.0, 2.20, 2.21, 2.22, 2.23, 2.24, 2.25 is going to be this value. Yes or no?
So
Check.
negative 2.25.
Whenever it is negative 2.25, you start with the first two values, negative 2.2. So the first value is
Yes.
negative 2.20, 2.21, 2.23,
1,
2.24, 2.25. Right?
0.2.20, 2.21, 2.22, 2.23. It's the one after that, sir.
Yeah.
The
0,
one to the
1,
right
2,
of where you put
3,
it.
5. Is it the value?
Yes, sir.
There may be some. Yes. Just a second. It is. You are right. So without any issue, I'm writing this value. This is the probability. And this probability is going to be, if I can write down, it is going to be around 1.2% without any issue. Yes or no? Is it okay? Is it
Yes, sir.
1.2% approximately? Now tell me, what was the level of significance? Level of significance is 5%.
5%.
Is it
This
less than
is less than
5%?
5%. Yes,
That
sir.
means the value of Z correspond. That means if you mark X bar less than 67.3, the value will lie in the region of rejection. Yes or no? Somewhere here.
Agreed.
So that means
Yes.
our value lies in the level of in the area of rejection. So we need to reject the null hypothesis.
Right.
So if you wish to use this, you can use this, but for this you need to use the table. And if you use the z value, you can make use of the table given to you. This is the table sufficient, and the values are given to you. Like 1.645, the value is already given to you. You can make use of the table. This table is the same what we did in the beginning. And for this type of question, you need to refer to the normal distribution table. It is up to you.
Okay, sir.
Okay, so I prefer to use the G value question, because for that you have a table and you can easily find out the values without any issue. Right?
Right, sir.
Let us talk about the second type of question. Earlier the situation was the population is known to be normal. Look at the situation. This time the population is not normal. The population is not normal, but the variance is known to you. And
Population's
the
not normal, but the variance is known.
No, and the sample size is large here. Sample size large stand for by default it should be bigger than 30, like we discussed in the previous question. So even though I do not know about the population, which is not normal, but yes, using CLT, I can predict that this X bar is normally distributed with the mean mu of the population and the variance sigma square divided by n. The same thing without any issue. The only thing you need is n is going to be very large. Very large will mean n is bigger than 30 for you. And the question will be the same. Whatever we did in the previous question, it is going to be the same for you. Let us have a
Okay,
question
sir.
based on the same. Read the question, please. The management of a large hospital states that mean age of its patient is 45.
It's 45 years.
This is mean mu given to you. Records of a sample of 100. Sample of 100, that means n equals 100 given to you. Mean age
Yes, sir.
is going to be 48.4. So I hope the sample mean is 48.4 given to you, right? Using
Yes,
the
sir.
standard deviation, sigma is going to be 18 given to you, and level of significance is 5%. Whether there is evidence that management's statement is incorrect, not increasing, not decreasing, it is incorrect. What is the meaning of incorrect? By default, my null hypothesis is mu is going to be what is given to you, that is 45. Alternative stand for this mu is not 45. That is that is only when it is incorrect. Right? They're not talking about increasing or decreasing. They're talking about it is incorrect. So it is a two-tailed problem.
Okay,
For a
sir.
two-tailed, alpha is going to be 5%. I need alpha by 2. Alpha by 2 is going to be 2.5%. That is 0.025. Right? Can you just check the table you shared with me and tell me the value of Z alpha? Let me just go to
For
the table.
0.025, it is 1.96.
1.96. So basically, I made use of the table. Any doubt up to this point?
No doubt till this point.
Okay. So this is going to be Z equals 1.96 without any issue. Okay. So now
Okay, sir.
let us just try to find out the situation here. Let us just try to find out what is the Z value. Z value is going to be X bar, the sample mean, minus mu naught, whatever given to you. Mu naught is 45 for you. Divide by sigma over square root of n. X bar is how much? It is 48.4 minus 45. Divide by sigma is 18. Divide by square root of 100. Can you use your calculator? Tell me the value.
Yeah, it's 48.4, right? So 4 point.
Yes, it is 48.4.
So it would be 3.4 divided
Minus
by
this divided by 1.8.
18 divided by root 100. So 1.8, yeah. So it's coming 1.8 dot. 1.8 continuous, basically.
1.88.
Yes.
So always remember, whenever you are discussing two tails, so the situation is like you are having a situation. This is going to be area of rejection. Area of rejection. It is 2.5%. This is 2.5%. And the value of Z alpha, like you told me, 1.96 from the table. Right? The value of Z we obtained is here, 1.88. This point is going to be represented by 0. Yes or no? So basically,
Yes.
what we have obtained that mode of Z, it is less than mode of Z alpha. Mode of Z alpha stands for 1.96. Am I right?
The thing we
Yes.
calculated from the table, 1.96. Yes, sir.
1.96. Yeah. This is what we have obtained, and this is what we have calculated.
So
This
it
is the
can be
calculated part.
accepted in this case.
So yes, so we are not going to reject a null hypothesis. We do not reject null hypothesis. We write do not reject null hypothesis. So the change is not significant. So how should you answer the question? The answer is going to be like, just read the following para and you will be able to get the answers. The test value is 1.88. This is what you told me. Since mode G is less than, do not reject H naught. There is not sufficient evidence at 5% level of significance to reject the management's claim that the mean age is 45.
Right.
You got it? So that is all. So I hope you get the idea. There is a third type of question. This is the final one for Z values using the distribution. Then after we'll be moving towards binomial. In this case,
hypothesis testing with binomials.
Yes, we will be discussing after this topic. So testing of mu, in this case, for the population is unknown. The variance is also unknown. Earlier in the previous two cases, variance was known. This time variance is unknown. And the sample size is going to be very large. So in this case, we need to somehow find a variance because I'm going to apply the same formula. I'm going to apply the same formula, x equals this x bar minus mu over sigma upon a square root of n. I'm going to use the same formula. Everything will be same. But the question is, this time I do not have variance. Yes. So what we do, in place of sigma, we use estimate. We use unbiased estimate of sigma. Unbiased
estimate.
Estimator. Yeah, estimate of sigma.
And how would we get that, sir?
Yes, I'll tell you about this. So for the samples, we have S square defined by summation x minus x bar whole square divided by n. And the unbiased estimator denoted by sigma hat is going to be multiplied by n over n minus 1, this S square, which is basically summation x minus x bar whole square divided by n minus 1. This is called the unbiased estimator. So that means to say that
n minus 1 sigma squared.
S square. It is S square.
S square.
It is equal to summation x minus x bar square divided by n minus 1. Now the question is,
stands for, sir?
This S square stands for sample variance. It is sample variance.
Okay, the variance of the sample will give in the example of the question. Like once they give the actual one and then they give the sample one.
Yeah. So unbiased estimate is denoted by sigma hat. It is defined like sigma hat is going to be n over n minus 1 S square, or when you just plug the value of S square, simplify, it is just replacing n by n minus 1. Any doubt?
No doubt, sir.
Now the problem is we may not be having situation like where we can find x minus x bar. We need a better formula. The better formula will be, you need to learn this formula. This is for sigma hat. The formula is It is summation x square minus summation x whole square divided by n. Okay.
Okay, so
This is the formula you will be using, and using this formula, I will be replacing the value of z by this formula. I will be calculating this
it's
value, and my all the observation, rejection, or acceptance will be based on this formula. Any doubt?
so 1 upon n minus 1, sum of x squared
Sig
minus.
x square summation x whole square divided by n.
Okay.
I'll show you one question. Please be ready with the pen and paper. Have you noted these values? Because I'm going to use them. Just note
Just
down
a
for the
second, sir.
moment. The packaging on an electric light bulb states that the average length of life of bulb is 1000 hours. It is given to you. I can consider this as mu. The consumer association thinks that this is an overestimate. It is an overestimate. That means actually is less than 1000. Test a random sample of 64. That and this is the value of n for you. Recorded that summation x is this one 63910.4 summation x and summation x square given to you. First of all, they are asking you to calculate the mean. Mean is going to be x bar is going to be summation x divided by n. Summation x, like they told you, 63910.4 divided by 64. Can you please help me? What is the value using calculator?
Yes, sir. So 63910.4 divided by 64 is 998.6.
998.6. Is there any difficulty up to this point?
No, sir, no difficulty.
Perfectly okay. Now look at the B part. Calculate an unbiased estimate for the standard deviation of the length. Unbiased estimate, that means they're asking about sigma hat, which is 1 over n minus 1, n is 64. Summation, I told you x square, the value of x square is given to you, minus summation x whole square divided by n. I'm going to plug the values. It is 1 over 63. This is 638246061 summation x square minus. Please help me divide by this 64. 63910.4 square. Can you please
So
do
1
the
by
calculation?
63. Just a second, sir. 638246061
Yes.
minus
Bracket is started. Parenthesis 63910.4 whole square divided by 64.
63910.4
I
squared
forget to
divided
mention it
by
is
64.
I forget to mention it
I'm
is
getting
sigma square. And this is sigma square actually. So that is a mistake because it is variance. Variance is sigma square by default. Yes.
So I'm getting 49.77.
Perfectly okay. You get the right answer, 49.77. This is the variance. So if I ask you sigma hat is square, sigma hat is going to be square root of 49.77, which is going to be 7.055. So I'm just sharing with you the calculation they did and you did. Both are going to be the same for you. Just check. I hope it should be readable. Can you please check? Both the values are same.
Yes, sir.
Okay, so up to this
It's the
point,
same
not an issue.
style.
Okay, so we are able to find out what is the unbiased estimator. So let me just talk about the C part. C part is based on the hypothesis testing. Is there evidence at 10% level of significance, alpha is 10%, that the substance on the packaging is overestimating? Overestimating. That means null hypothesis says that the average is 1000 hours. And the alternative is it is less than 1000 hours, then only it is overestimate. Yes or no? Company
repeat,
claims
sir?
that the average life of the bulb is 1,000 hours. But when you are testing, it is observed that, or it is basically the claim that the company has overestimated the length of the bulb life. So that means actual mu is going to be less than 1,000. Yes or no? Then only it is overestimate.
Yes, sir.
Did you get the meaning? Just suppose actual is 950. Company claimed 1,000. So what company did? Overestimated. Right? So this is the situation they are discussing basically. So let me just now. What was N? N was 64 in this case without any issue. The mean we obtained in part A is 998.6. 998.6. Sigma hat
Yes.
we obtained like 7.055. So let us just try to find out the Z value.
We can
Z value
use
X bar minus mean, that is mu,
the
not divide by
1
sigma
root.
over square root of n, right? X
Yeah.
bar is 998.6 minus mu is 1,000. Divide by sigma, that is 7.055, divide by square root of how much? 64. Square root of 64, I can write 8 directly. Can you use
Yes.
calculator to calculate this value?
So 998 minus 1,000 is, sorry, 998.6, right?
Yes.
It will be this divided by 7.055 divided by 8. So I'm getting minus 1.58.
Just tell me minus 1.5, minus 1.5. Let me just check the value. Yes, minus 1.587.
Yes.
Right? So remember, because normal distribution is symmetric and we need to use a table. So for 10%, P is going to be 1, so 0.1. You need to find Z alpha. And because it is left tail, so the value you will be using negative Z alpha. Okay, so this is the value you will be using for the testing. If the value of
Yes.
Z, it is less than negative of Z alpha, you are going to reject the null hypothesis. Okay, that is mu is 1,000, otherwise no. So let us just find out what is the value of Z. For this, I'm going back to the table. And in the table, you just look at 0.5, no, look at 0.1.
Is 1.286.
It is going to be 1.2816. Am I right?
Yes, sir. So that means the area of 0.1 on this is 1.286.
1.28. Perfectly okay. So which is going to be, is it less than negative 1.286? Yes or no?
Yes.
Okay. So that means the value of Z we obtained, it is on the left side of the this. It is in the area of rejection. So what should I do? I reject null hypothesis. So yes, that means I'm going in the favor of the alternative hypothesis. Yes, the average is going to be less than 1,000. It is overestimated. It was overestimated. You get the idea?
Got the idea, sir.
Okay, and let me just share with you the solution, how they did it. Can you just read this solution and tell me if it is the same thing what we have learned? Check the value of Z they obtained. Check the value of Z alpha negative 1.282 at 10% level of significance. I got the value from the table. It is the same value. So the value of Z, it is on the left of Z alpha. So you need to reject H naught. So basically our answer
Because
is
it's in the
yes,
rejection
because
area.
Yes, because it is in the area of rejection. There is evidence at 10% level of significance that the statement on packing overestimate the length of the life of the bulb. Is there any doubt? Is there any doubt?
No, sir.
Exactly. Okay. So this is the first type of question.